generate DSM and orthophoto from the UAS data in Agisoft Metashape Professional. So we start with the empty window. Here's where our model is going to show up, and here are our two tabs, Reference tab and Workspace tab. First, we're going to start with loading our photos, and I would like you to see, like, we work right now in the local coordinate system. We don't want that. For the aerial data, we want to work in some kind of the known reference system, maybe latitude, longitude, altitude. You can change it here for WGS84, which is longitude, latitude, altitude, or you can search for the reference system that your data is in. So we start, workflow is something that we're going to be pressing a lot. So here is our step by step, what we're going to do. First, we're going to add photos from the folder. I'm adding all of them. These photos are downsampled, so the processing will go faster. You can see here that the positions of the cameras are not loaded. Also, you can't see the cameras here. It's because this type of UAS that was flown, it's a Trimble UAS, it does not save the information about the picture localization in the EXIF file. It does save it in a separate log file. So I need to log it from the log. I'm double checking latitude, longitude, altitude, yes. And I have the rotation. I want to save to load it with the rotation. In this, and right now we can see the grid here, or our photos are located somewhere within the reference system. So this is the center of the photo. The next step is to align those photos. So the generic preselection takes much more time because it looks, for example, for this photo, for tie points in all the photos. The reference preselection has a preference for the photos that are in the vicinity, so around. It's looking more locally. So we can use if we have ground control points to optimize the alignment, we can use lower alignment or a medium one, like in my case. I'm going to be using medium. It's going to take some time depending on the resolution of your photos and also on the number of the photos and of course on your computer performance. So in my case, because we have just 70 photos, 78, and they're downsampled, so it just took a couple seconds. So we can see all our photos are aligned. Don't worry about the bounding box color. It can be changed. It's just my preference to have it green. Bounding box is to indicate what area or what points. You can see here the sparse point cloud. What points will be taken into consideration in further processing. So I want to rotate. Here you can rotate region, move the region. So I want to rotate it a little bit with the ball, so it will just have all the photos. Okay, you can see here what's important. The red is the bottom, so the red is supposed to be underground, the base. We can see here that all the photos, all our points are within the bounding box. Okay, so the next step is to load our ground control points. Open, and in this case, I have tab here. I have just latitude, longitude, and latitude. Of course, there is no rotation angle for the ground control points. I have just 3 for this flight. It is optimal to have at least 5. But this is just for display, so I will do it faster, and you also can do it faster on your computers just with sample data. Here I press yes to all because I want them to be, and now there is a time. I have a separate video on how to locate the ground control points, so I'm going to pause it here and I'm going to indicate it on all the photos. So I'm just going to show you how I'm going to do it. Filter photos by marker. I will start with the 6th one, and I'm going to move this little flame, I think it's a flame, to the center of my ground control point, and I'm going to do it with all the photos that I have. So I'm done with locating all my ground control points. You can see here, I've located them on over 20 pictures each because we had a really significant overlap, like I think 80% side overlap and forward overlap too. So my next step would be for optimizing alignment. You have here this magic wand here. So what I do, I check all of the boxes. There are different coefficients associated with the optics of the camera. And I press OK. And now the whole point cloud, the sparse point cloud, is adjusted based on these ground control points. You can see how it changed here. I was showing you before the error was about like 30-40 meters, and here we have 0.001, so it's like less than a centimeter. So what's our next step? Remember not to realign the photos after you optimize the alignment. Next step is usually the most time-consuming step, so you need to make sure that you don't ever use the ultra-high setting because it's just going to crash for you. We're going to use the medium settings in this case. Here you have the depth filtering. Mild is for the models or for some very complicated textures. You don't want to filter all the outliers. We're going to just do the moderate, and we definitely want to calculate the point color. So I'm going to click OK, and it's going to take me probably a minute. So I'm going to be right back. I'm done with the processing, and here I can activate and see my sparse point cloud changing into dense point cloud. So this is the sparse one, this is the dense one. Our next step with the workflow is to connect all these points that we created into triangles. So build a mesh, triangulated network. We want to use as a source data the dense cloud. So surface type, we want a high field because we are working with aerial data. If we would be working with a model, we would use the 3D, and that takes much longer. And here is the face count. I like to have a really beautiful model, so I like to keep the face count high. So I would do even the custom, maybe 5 millions, but I want to have the enabled interpolation and of course calculate the vertex colors. I click OK, and it's going to take a little bit less time. I'm going to post below what are the parameters of my computer that it works so quickly on my computer. And this is ready. So this is active now. I can see a model here. Let us look. You can see how the trees look like towers because the only data we have is about the surface of the crowns. We don't have any data from below because we have flown just so high. So the next step is to build the texture. The mapping, I want to create orthophoto or an adaptive orthophoto, so I'm going to click that one. Adaptive orthophoto takes the flat surfaces and applies different algorithms to the flat surfaces into the nearly vertical surfaces. So I'm going to click OK, and it's all going to take probably a couple seconds. So the texture is ready, and what is left now is build the DM and build AutoMosaic. If you're working in the demo mode, you don't have license, it's not going to be active because you need to be able to save files in order to build the DM in AutoMosaic. So I am choosing my own coordinate system. I'm in North Carolina, so this is 3358, the EPSG. And you need to remember that whatever coordinate system you use for your DSM, the same coordinate system will need to be used for the orthophoto. And our resolution is here 25 centimeters, so about 10 inches. Generating DM, it's going to take probably a couple seconds. Ready. And next, I will build AutoMosaic. As you can see, I have no option to change the coordinate system because the only what I have is what I've chosen for the DSM. So yes, the surface is the DM and the mosaic, and I just click OK. It's going to probably take a little tiny bit longer than for the DSM because the resolution is higher. And now in my workspace panel, I can see the generated results. So this is the DEM and the AutoMosaic with the C lines that I created. The next part, what I want to do is export all the files. So you go to File, Export, and here we can export the Pointcloud, the model that we built previously, that you can also upload it to one of the online web servers that store your maps. I use Sketchfab. So I want to export AutoMosaic, export the DM, and save it as whatever extension you need. What's really cool about the Metashape is generally the processing report. It's really great to have it. This is like either sample, and you will see it will create a PDF that will tell us a lot about our processing. So this is my report. Shows the overview of the orthophoto, shows what was the overlap, how many camera stations, how many pictures were aligned, the camera calibration report, the camera locations with errors, camera orientation, the ground control points here with the error. We just had 3. It's really not advisable to have it like what we had in one line. It's best to have them on near the corners of the area and then one in the middle. And it also shows us the digital elevation model and our processing parameters with the times for processing. So fortunately, it was not very long. If you have a lot of photos and your computer is not as fast, it can take you hours and hours. So this is it. I hope you enjoyed it, and good luck with working with Agisoft Metashape.